Hey guys, welcome to my second video on VCE tutoring. This time I'm taking an example from Mathematical Methods CAS, and this will be relevant for Year 12s that are learning how to sketch the inverse of functions. Specifically, we're going to take an example today that has an e to the x, an exponential graph, and the inverse of this, which is going to be a logarithm. So basically, I want you to just imagine as a student sitting next to me. As we go through this question worth 8 marks, we're going to go step by step through each of the parts, and I'll show you basically a model answer to ensure that you get the maximum amount of marks or consequential marks should you happen to make a mistake. So the question, for 8 marks, for the function f such that r maps onto r, f of x is equal to 2 e to the x minus 1 minus 2. A, state the domain and range of the function. B, find the inverse of the function. C, state the domain and range of the inverse. D, sketch the line y equals x, y equals f of x, and y equals f inverse of x on the same set of axes, labeling all axes intercepts and asymptotes for 3 marks. So this is really the key part of the question, is on sketching the graph. And then finally in part E, find the coordinates of the points of intersection of the graphs of y equals f of x and its inverse. And at this point here you'll need your CAS calculator. So we'll get stuck into it. So part A, in order to find the domain and range of the function, I like to just consider the transformations that have been undertaken from the basic graph of y equals e to the x. So if we look at this, we have a dilation of factor 2 here from the x-axis. We've moved the graph to the right by 1, a horizontal translation right, parallel to the x-axis, and a vertical translation downwards by 2 units parallel to the y-axis. So just doing a quick little sketch here, you can imagine that from the basic graph, my new graph would now look something like this. It's my e to the x graph, and with that translation downwards at y equals -2. Okay, so if we consider the domain and range of what I've just drawn here, we can see that the domain of f is equal to all real numbers. So x can take any value from -infinity to positive infinity. And note that that's also just told to us here in the question. Now, really the sketch helps us with the range of f, which in our case is from -2. Note that I do not include -2 because it is an asymptote. So that's part A done. Part B, in order to find the inverse of the function, I essentially need to swap the x and y. So I'll just write out the current equation, 2 e to the x minus 1 minus 2, and now I'm going to swap x and y. Okay, so when I do that, I get x equals 2e to the y minus 1 minus 2, and now I'm going to solve this for y, and this is where I'm going to start to use log laws. So in one shot I'm going to add 2 onto this side and divide by 2, so I get e to the y minus 1 is equal to x plus 2 over 2. Now in order to bring that exponent down, I'll take the natural log of both sides, so I'm going to be left with y minus 1 is equal to the natural log, and I'll just rewrite that as a half x plus 1. So note here that I've just used ln as a shorthand for the natural log, and I've also skipped a step here just to save some time. Now I then add 1, so y is equal to ln of 1/2 x plus 1 plus 1. Okay, so I have now found the inverse of the graph, so therefore f -1 of x is equal to the ln of 1/2 x plus 1 plus 1. And that's the answer to part B. Okay, back up with the question. Part C asks for the domain and range of the inverse. Okay, now there's a little neat trick here. With inverses, just following on from the theme of swapping y and x, I simply swap the domain and range around from the original function to get the new domain and range for the inverse. So what I mean by that is the domain of the inverse is equal to the range of the original, which is equal to -2 to infinity. The range of the inverse is equal to the domain of the original, which is equal to all real numbers. Now note that if I wanted to, I could just do a quick little sketch again to just have a think about what this graph actually looks like. So we know, hopefully you all know the shapes of log graphs. You've learnt that in school. I will have an asymptote, so when x equals -2, this becomes 0, and as you know, the log of 0 is undefined, so that is x equals -2, and my log graph would look something like this. And you can see from that your domain will be from -2 up to infinity, and again note that I don't include -2, and this time the range can be anything negative infinity to positive infinity. Okay, part D. We're going to be doing the sketch now on the same set of axes of these two, so I'll simply be drawing this one and as well as the log inverse, as well as the line y equals x. Now in order to do that, I actually need to figure out the x and y intercepts. Okay, so I'll start off with my first graph, so y equals 2e to the x, 2e to the x minus 1 minus 2. So for the first one, for my y-intercept, I let x equal to 0. So y equals f of 0, that is equal to 2e to the minus 1 minus 2. Now this is simply a number, so to keep it in an exact form, I would leave it as 0, 2 over e minus 2. Now just to get an idea of how to sketch that and how to draw it on the axes, I'll just punch in 2 divided by e to the 1 minus 2. So as an approximate, negative 1.264. Okay, now to find the x-intercept of my initial graph. So the x-inter dot dot y equals 0. 0 equals 2e to the x minus 1 minus 2. So then I'm left with e to the x minus 1 is equal to 1. Now if we can consider this, in order to solve this, this power up here, this power up here, x minus 1, must be equal to 0, which means that x equals 1. So I now have my x-intercept at 1, 0. Okay. Now I'm going to do that analysis of x and y-intercepts again, but this time for the inverse equation. So f negative 1 of x is equal to the natural log of 1/2 x plus 1 plus 1. Okay. Y-intercept dot dot x equals 0. F negative 1 of 0 is equal to ln of 1 plus 1. Now we know that log e 1 is 0, so 0 plus 1 is 1. So I'm left with the point 0, 1. And finally my x-intercept dot dot y equals 0. So 0 equals ln of 1/2 x plus 1 plus 1. Now I get, so I'm going to subtract 1 onto this side, and I'm going to reverse that log into its exponential equivalent. So 1/2 of x plus 1 is equal to e to the power of negative 1. So I've kind of combined two steps there. Rearranging this again, I would subtract 1 onto this side and then double everything. So I would be left with x is equal to 2 e to the negative 1 minus 2. And in coordinate form, 2 over e minus 2 comma 0, or as we worked out before, negative 1.264 comma 0. Now guys, you'll note here that the x and y intercepts essentially swap around between the two graphs. So up here where I had my y-intercept at 0, 2 over e minus 2 for my initial graph, you can see down here that it's actually swapped, and it's now become my x-intercept. As well as up here, I had an x-intercept of my initial graph at 1, 0, which has now swapped around and become my y-intercept at 0, 1. So that all lines up nicely. So now I'm ready to do the sketch of the graphs. So I just grab a new page. Okay. Now, in order to set up, I'll show you how I like to, this is D continued, how I like to set up the axes in order to draw this question, draw this graph up. So I like to try and focus in on, or scale the axes to show the important points of the graph. So I kind of want to focus in more on this area. Now the paper that I'm using is about 7 millimeters lined in the vertical direction, and I'm just going to use centimeters on my x-axis. So it takes a bit of practice to get the speed as well. Okay. Okay, so I'll go up in 2s. And again 2s. Okay, so for the first graph, looking back here, I'm going to plot my intercepts. So I had a Y-intercept at 0, negative 1.24, so it's about here. An X-intercept at 1, 0, so that's here. And remember, as per the graph that I drew earlier, remember this one over here, this is a shape. So I've got my asymptote, which I'll sketch in. Draw the asymptote in black. So there's an asymptote. Okay, so this is the asymptote. Y equals negative 2. And using a pencil, I'm going to sketch in the shape of this e to the x graph. And remember, it's a sketch, guys. So as long as the shape is there, it's consistent. Right, and then I'm just going to label these points in here. So to the decimal places, 3 decimal places. And I will write the equation next to it. F of x is equal to 2 e to the x minus 1 minus 2. Okay, now I'm just going to draw in the line y equals x. I'm going to just score that lightly in here. Okay, so this is my line y equals x. Now I'm going to draw the inverse graph. So remember, that was the log, so it's going to look like this. And the asymptote is now vertical, so do it in green here. Okay, so this is the asymptote at x equals negative 2. And again, I'm going to put in my intercepts. So remember, over here, the x-intercept was at 0, 1. Sorry, the y-intercept is at 0, 1. And the x-intercept at negative 1.264. So that's about here. Okay. And now the shape will look something like that. And I finish off by writing the equation. F of x is equal to ln of 1/2 x plus 1 plus 1. Okay, so there's my graph. Also make sure I label all of those points. And that completes the question, guys, for the sketch. And now the last part, part E, find the coordinates of the points of intersection of the graphs of y equals f of x and y equals the inverse. So there's two ways I can solve this. I could make, the harder way would be to make this equation here, my original, equal to this equation here, and then solve. There's quite a lot of algebra manipulation in there. The easier way to do it is to note that the 2 points that I'm solving for is here, that intersection, and here. And they actually occur upon the line y equals x. So to solve, the easier way to solve for part E, intersection of graphs the original graph equals its inverse when y equals x. So I'm essentially solving f of x is equal to x. So my initial equation was 2e to the x minus 1 minus 2 is equal to x. And as I said earlier, at this point you would use your CAS and you end up with x equals negative 1.889 or 1.583. So the corresponding coordinates of the intersection, so remember it's simply y equals x, right? So it's the coordinates match, so we're negative 1.88, negative 1.889 and 1.583, comma 1.583, and if I come back up here, that's exactly those 2 points here. 1.583, 1.583, and in here, negative 1.889, comma negative 0.889. Okay. Now that is finally the end of the question. Now, just looking back, guys, as a marker's perspective, remember this was worth 8 marks. So you would get 1 mark in here for a correct domain and range, 1 mark in here for the working to find the inverse, and then another mark for the correctly stated inverse, 1 mark for the correct domain and range of the inverse. Now, part D for the sketch was worth 3 marks. So it would be a correct mark in here for the intercepts of the original, mark in here for the intercepts of the inverse, and another mark for a complete sketch showing all asymptotes and intercepts labelled correctly. I've done them all here to the 3 decimals to approximate, so mark for that, and then finally a mark for the correct part E. Thanks for watching, guys. As always, feel free to like and subscribe to the video. Good luck with methods.